Hold on a second. Go down to smaller size. We're recording. Now let's turn on Audacity. Oh, now I'm hearing all kinds of noise. That's it. That's just from your end. All right. Pete Giuliano. It is Friday, the 5th of May, 2023. Pete, what number is this?
SolderSmoke 246. Crank it in, Robert. Crank it in, Ralph. And happy Cinco de Mayo.
That's
happy
right.
Cinco de Mayo. And if you were born in February, you might trace your roots back to Cinco de Mayo.
It's something could have happened in February.
Yes.
For all of you with February birthdays, happy Cinco de Mayo.
Yeah.
Pete is a real Californian kind of guy. He'd remember Cinco de Mayo, man. It's really pretty cool. Thank you, Pete, very much. Listen, Pete, I think the first thing we need to talk about is something that's been of concern to a number of our listeners, and that is the threat from AI, the threat from deep fakery, and it reared its ugly head here in the last couple of podcasts, because I pointed out that not on the last one, but on the one before that. So let's see, 244. There was a technical problem. You had some sort of Skype glitch. And so we turned to our friend Dean, KK4DAS, who has a lot of experience in this area. Dean said, don't worry. We'll use AI and deep fake to fill the gap in the program. And I just thought to myself, wow, this opens up all kinds of wonderful possibilities. I could have Pete Giuliano.
No way.
Decrying the SI 5351, pouring scorn on Arduinos, and fully embracing analog VFOs and PTOs tuned by nothing more than a piece of brass screw. I said, Jesus, this is like a new day has dawned here in SolderSmoke, And we got a lot of email. One guy, the funny thing about the email is that people objected to different parts of the story. But one of the interesting thing is that they objected to the only part of the story that was really true.
Yeah.
One guy wrote in and he said, when I heard you guys mention the intelligence community, I knew it was all bogus. That's the only true part.
Yeah.
Pre-retirement, Anyway, the important thing about that story was the publication date, which was, after all, April 1st.
Oh, yes.
Right? And the whole AI deep fakery thing, listen, I want to ask right now. I'm going to ask something of the SolderSmoke audience. We don't ask for a lot. Most of this stuff is just free, as it should be. But if you were at all sucked in by this story on the April 1st, if you found yourself thinking, wow, that really wasn't Pete. That was deep fake Pete. That was AI Pete. That was PeteGPT, If you found, even for a moment, if you found yourself thinking that way, please send me an email and fess up, okay? Because we want to keep track of, how many people were kind of caught up in this whole April 1st thing. And we had one guy who did, I'm not going to mention names or call signs here, but we did get a message from one guy saying, hey, can you please tell me the portion of the show in which Pete was deep faked and AI'd? Because I don't want to go sit through the whole thing because it's like an hour and a half. And I just said, well, I'm sorry. We've offered a prize here and it would be unfair for me. So, but he never got back to me. I have a feeling that he got clued in, but that was an indication that once again, our April 1st story has actually caught a few, Pete. Unbelievable as it may seem, but it was very timely. So anyway, please send in. Don't worry. We promise to only put the real deal here, the real Pete Giuliano. There'll be no deep fake Giuliano, no AI Giuliano, no Giuliano GPT, nothing like that. It's going to be the real deal here. So I people should rest assured, right, Pete?
Yeah.
Okay, good. Second thing I wanted to mention. Listen, this is this is going to get into the 75 meter territory. You know, people say that 75 meters has become like an organ concert because all these guys sit around and do this, talk about their various ailments and organs. But this is a technical nexus here. There's a nexus here with what we talk about, and that is my quest for hearing improvement. So I got high frequency hearing loss. It has been documented by the Veterans Administration. They gave me some hearing aids a while back, but I kind of didn't like them because they were kind of uncomfortable. I had to stick it into the ear canal and walk around with this thing riding on the back of my ear. Didn't like it. So I went back. They're going to give me another one. But in the meantime, I found out something that may be of interest. And I know it's of interest to many of our listeners. And that is that the modern AirPods, these white things that you see people walking around with in their ears, they have little microphones on them. And you could set it up with your phone. So these things serve as hearing aids. So on a recent visit to the audiologist at the Veterans Administration, she gave me a piece of paper with my audiogram on it. And I got home and I was looking at the phone and I said, how could I get this information into my phone? Well, Apple's got a thing for that solution. You just take a picture of the piece of paper and you tell it to upload it, and it does. And it automatically changes all the settings in your phone.
Wow.
For music, for video, for phone calls, and also for the little microphones that you've got riding up on top in your ears when you got these things in. Pete, it was amazing. There's rock songs that I've been listening to for 40 years. I never knew that they were playing the cymbals, the high frequency stuff. I couldn't hear the cymbals. When you turn this thing on, when the iPhone adjusted to my hearing loss, suddenly I can hear the cymbals.
Wow.
So really kind of an interesting thing. Also, the business of my hearing losses, usually it doesn't cause me any trouble at all. But the other day, and I'll talk about this in a minute, Dean and Mike and I were over at the high school, and we were testing out some of the receivers that the kids had built. And Mike was way over on the other side of the lab with his transmitter, and he was sending CW. And I was standing there, and I looked at Dean, and I said, "It's not working. I can't hear him." And he looked at me, and he goes, "I can hear it just fine. It's just high. It's outside your range." So somebody wrote in. They said, "This is great news, Bill. You've got an audio low pass filter built into the head."
Yes.
Thank you, U.S. Army. Yes, great. Okay, so now I can hear the cymbals. But listen, I've been talking to somebody else who's interested in this kind of thing. You have to kind of fool around with the iPhone a little bit. It's sort of like an ICOM 7300 when you have to go through and set the menus and press the buttons and do the settings and all that, which can be kind of frustrating. But once you crack the code, it's worth it. So anybody out there who wants help in cracking the code, let me know, and I could send you some pictures, some screenshots of my settings. I could be like the guy with the 7300. Well, man, you got to change setting number 53 to 72A because it'll get a little bit more brightness in your right. No, we're just worried about the response of the AirPods. So good news there. It's been great fun. I can hear the cymbals, Pete. Hey, I wanted to mention you had asked about this, the direct conversion receiver project at the high school. Well, the last time we talked, I was kind of gloomy about the whole thing. I thought the whole thing had come to a kind of a screeching halt, but no, it didn't. It started up again about a week ago, yesterday, and then we've had 2 sessions since then. We have been brought back by popular demand. The students who were working on these things asked that we be brought back, which is great, which means that there's real interest in this thing. So we went back a week ago, and we were in the final stages. We had completed all 4 boards, but now we were just trying to hold on. Guapo is barking. Hold on. Guapo. Close the doors.
You need to take 1 second and explain what guapo means, because it was just demonstrated, right?
Guapo. Guapo is the dog. Guapo is the Maltese dog. And guapo is kind of a slang term in Spanish. It could mean two different things. It could mean either tough guy or good-looking guy, or good-looking tough guy, I guess. But anyway, guapo. It depends on the day of the week and his mood. Sometimes he's the good-looking guy. Sometimes he's the tough guy. He'll bite you.
You heard the tough guy.
He's a Maltese. He's eight pounds, but man, he bites. Watch out. But anyway, I was telling you, we were brought back by popular demand, and because the students wanted to finish their devices. We had built all four boards. We had built the RF amplifier, the mixer, the bandpass filter, and the audio amplifier. And we had tested all four stages, but now it became kind of device integration, board integration. Pull the four boards together and test it to see if this thing is working as we knew it would work. You know, one thing I would say, there's kind of you kind of live and learn. You go through this process, and there's things that you learn. We kind of just assumed, I think, that, well, once we got the four boards together, it would just be a piece of cake, putting them all together and coming up with a working receiver. And we kind of forgot that not really, that there's, even if you know all four boards are working right, especially for people who've never done this before, it can be a bit tricky pulling it all together and getting the receiver to work right. So that's where we are. I think in the future, we probably would allocate more time to this kind of system integration phase and getting the receivers working. But we were back last week, and we were back yesterday and a week before. And so far, I think we've got 4 of the receivers working, 4. And we've been invited back twice more. So our hope is to get, I don't know, maybe 6 or 7 of them working, which will be great. But one of the things I think we're going to have to do is, ironically, we're going to have to go out of the lab, because the lab has got so much electronics and noise and rebar around it. It's almost like working in a Faraday cage with a lot of noise on the inside. So we'll probably have to go outside. This will give us an opportunity to demonstrate to the students how to put up an antenna. We're going with a little quarter wave antenna, little wire antenna, no coax, nothing, just right out of the bandpass filter, boom, the antenna goes out. And let them, start experimenting with and listening to 40 meters. So it's definitely got their interest. They're clearly taking pride in working with something that they've built themselves, but they really haven't had the experience yet of having this kind of thing around where they could just turn it on and listen. And you might say, oh gosh, 40 meters. Why are you guys making them listen to 40 meters? Well, there's some interesting stuff on 40 meters. Early in the morning, I have listened to Australia with this thing on 40 meter SSB. There's CW, and you could say these kids aren't going to be interested in CW, but they kind of are. They're intrigued by it, and especially by the kind offer of our friend Walter K84KXX down in Orlando, who's offered a reward, a substantial reward. I could say $500 for the first kid who builds a transmitter and then checks in to the sunrise net on 40 meters, which is, and I had a couple kids come up to me and ask me about that. I had to make clear that it had nothing to do with school. This is not a school thing. This is just a Walter thing. But thank you for that, Walter. But I guess I was kind of down last time about how many of these kids are truly interested in ham radio. That's still, I think, a legit question. These kids are interested in science and technology, or they wouldn't be in this particular school. So whether that extends to ham radio, or whether they're just using this as an opportunity to kind of explore some different kinds of technology, either way, it's okay. I mean, they're enthusiastic about it. They're working on it, and it's good. And not only that, it's almost good that we're down to about 6 or 7 receivers, because it means that the other 6 or 7 kind of fell by the wayside. Maybe because the students weren't really that interested in it. So we're sort of left with the people who are interested in, not necessarily ham radio, but with the technology and learning something about the technology. So that's pretty good. Anybody who wants to learn more about this project, we entered it into a Hackaday contest. Hackaday has a contest for technological education. We thought this would be a good one. So Dean and I put up a whole bunch of stuff and pictures, and I'll have a link to it on the blog page. But if you just go to Hackaday.io, Hackaday.io, and just search for high schoolers build direct conversion receiver, it'll take you to the page. But if not, I'll have the link up on the blog page, and you could just do it that way. What do you think about the project, Pete?
Oh, I think it's terrific, and obviously you pick some interest of a smaller group. So let's see, 4 receivers, four people per team, 16
Yep.
people.
Yeah,
16 out of 60 or 16 out of 50, something like that.
something like that. Yeah,
Yeah, that's a good percentage.
Back.
That's 30%. Yeah.
Yeah, and the other thing I said, and I came to realize this in the midst of my feeling kind of glum about it. Dean was good. Dean was a whole lot more patient than I was, and I kind of came to realize that look, it doesn't matter to us whether these kids finish this thing this week, next month, or 3 months from now. You know, when you're a teenager, your interests kind of wax and wane. You can be distracted easily. I know you were frequently you were frequently distracted, Pete.
Yes.
There may have been days where you were not completely taken by 10 meters.
Yes.
All right. So this can happen. That doesn't mean that these kids won't come back to this, you know, a few months from now or over the summer. Now we've left our email addresses with them and said, listen, if you run into problems
Sure.
and you want to pick this up later on, get in touch with us, which is something that you and I didn't have when we were kids.
Yeah.
If there wasn't
somebody,
if my rig didn't work and there wasn't somebody who was within bicycle range, that was it.
Yeah. Hey, I want to share something with you before I forget. And this is, you were talking about getting the radios outside so you could work. Well, my wife's in the hospital and she's been off and on here for a long time now in recent spate. My phone doesn't work in the hospital.
Oh man.
And the only way I can call out is I got to go outside and stand next to this light pole. I stand next to the light pole, my phone worked.
And you get a good signal.
Get a good signal. And I asked the hospital, I said, is this my phone? They said, no. The way this hospital is built is it's off the road and it's down below grade level. And it's just the repeater for my carrier, T-Mobile, there's not one close by, and it's really marginal. You cannot make phone calls inside the hospital. And if you got to call family and that sort of thing, let people know, got to go outside. I got to stand next to this light bulb.
That's terrible. That's, you know, really the solution is that the hospital should have a Wi-Fi network inside the hospital, free Wi-Fi.
Yeah.
You shouldn't have to rely on the cellular T-Mobile service. When you walk in, somebody should hand you a card and say, here's the password and the logon for the Wi-Fi in the hospital. I mean, we do it here in the house. People come to the house, they're going to stay a couple days.
Yeah.
What's the password for the Wi-Fi? There you go. Boom. You're on Wi-Fi. You don't have to worry about the cell service. Yeah. That's terrible.
So I've even had the phone search, see if there's something nearby. Nothing.
Oh, wow.
Nothing.
Oh man! All right. Well, we're gonna get Pete squared away. That hospital should have some Wi-Fi. I'm sorry to hear about your wife. I hope it gets better for you. I hope she's feeling better. But I know you've had a tough road, and we really appreciate you taking the time to come and talk to the podcast in the midst of all this personal trouble, Pete. So thanks again.
You bet.
Hey, but I talking about projects. Listen, you'll be pleased about this, Pete. I have been working more with Nanos and SI 5351 than I have for several years. I blame Farhan and Roger. Farhan because he created the MicrobitX, and Roger, PA1ZZ, because he sent me one of his. And now I'm in the process, of configuring SolderSmoke Shack South in the Dominican Republic. So I basically need 2 of everything. And I've got one MicrobitX that I've used for a long time, and I've recently done some mods on that. But the one that Roger sent me, I'm getting that one ready to go too. And I've been working on it. But Pete, I managed to blow up Nanos on, get this, wait a second. It's bad enough if you blow up one Nano. But then you say, wait a second, but I got another one sitting here. Let me just plug it in and make sure. You know, I had a problem with the MicrobitX, right? So this is the road to perdition here. So you got a problem and you think, oh, I don't know whether the problem is in the MicrobitX or in the Nano SI5351 combo. But I got another good one over there. So let me just pop out the SI5351 of this one and pop in another one and see if it works. And I managed to blow up both of them. This is when even Dean looked at me. He said, "How did you manage to blow up both of them?" And I realized how I did it. Now, the reason I did it this way was I had a very early model of the first MicrobitX. And when you look at the strip, the little strip that you connect the Nano SI53, what Farhan used to call a Raduino, when you connect it in there, there's supposed to be, well, there's 16 male pins and there's supposed to be 16 female sockets, right? Mine had 17 female sockets. So what I was doing was just shifting everything over by one pin.
Yeah, and pin 16 is hot.
And so pin 16 was hot, and it was going right in. Well, one of these pins was putting a lot of voltages on one of the outputs, and the Nanos don't like that. Poof, Nanos were gone.
You know, I often wondered about Farhan's design, because he could have put it on I2C and got the backpack, so you only have 4 wires going to it. In other words, the backpack plugs into the LCD display, and then you only have to parallel the wires to the SI5351, the 4 SDA, SCL, and 5 volts and ground. And I said, why did he do this? I mean, it would have been, you save the cost of the backpack. It's not that expensive, but you only need 4 wires instead of 16. And that would have saved you.
It would have saved me. I wouldn't have blown up 2, but I wouldn't have had the joy, Pete, of working again with Arduinos and Nanos and SI5351. But listen, in the midst of this, at least 3 different people came to my assistance. First, I'd like to thank Dean, KK4DAS, who took a Nano that I got and loaded the software, the code. We're all now using KD8CEC code. So I said, man, put KD8CEC code in this good Nano that I have. And the other thing is, the early models of the Raduino, they don't have plug-in Nanos. They have soldered-in Nanos. So I had to solder the Nano out, and the bad one out, and solder the good one in. But I got that one going. And then 2 other people took mercy on me, Pete. One is Sunil over in India. Sunil up in Uttar Pradesh in India. And his company is amateurradiokits.in. And they are still making and selling the Nano SI5351 combo. So if any of you out there need a Nano SI5351 combo, Sunil is the guy to talk to. And don't let the distance to India deter you, because Sunil can get it to you really quick. I mean, we put the order in, and within a couple of weeks, there was a box from Uttar Pradesh out of my front step. And his little combo, it has a really neat little SI5351 board with the 16x2 LCD on the top. It comes with a little encoder. It comes with the wires that you plug in. So really pretty cool. His website, http://amateurradiokits, all one word, .in. I'll have the link up on the blog.
Good.
He was even kind enough to load the KD8CEC software in there for me. So it came, and I didn't have to mess around. I didn't have to suffer, Pete, trying to get the software to compile and to upload like I used to do. But Sunil saved me from that. His company also has a new SSB dual band transceiver called the AirPal. So check out the website. So Sunil's company, thank you, Sunil, for helping us with that. And everybody should take a look at Sunil's site. It's a good source for the Raduino combo and a new SSB dual band transceiver, the AirPal. Another guy who helped me was somebody who's sort of taken over in a lot of ways from where KD8CEC left off, because KD8CEC pioneered a lot of the software, and software that Farhan himself has embraced as being something that you should upload, I think, into these machines that he created. I'm talking about Mark AJ6CU. Mark has been a big help, and he sent me two nanos loaded with the KD8 CEC software, and I put these in, and they fired right up. They worked. Mark was kind of curious about whether they would work right. They did, and he's got a piece of software that I really like. It's called the MicrobitX Settings Editor. This is sort of like the old memory maker that KD8 CEC had, which I found kind of difficult to navigate through, but Mark has really simplified it, and Settings Editor is really nice, and it's a free download from GitHub, and it lets you go in. You just load up you just connect it to the computer, and you can change a lot of the settings in the software. For example, when you switch bands, when you skip from band to band, what frequency do you land on when you go to 20 meters? Do you want it to go to the very bottom of the band, or do you want it to go to the middle of the band? Wherever you can set it up, you could set up that way, and it's really nice. So thanks to Mark for doing that. Hey, Pete, I've also been you'll have mixed feelings about this one, Pete. I've also been fooling around with Franklin oscillators.
There you go.
You know, this is an interesting thing because we have a guy in the club, actually two guys in the club, Lee and then Mike. Lee has been talking about Franklin oscillators. He wanted to build a Franklin oscillator and use it in an all band direct conversion receiver. He figured, well, the Franklin oscillator, you could get it stable all the way up to about 28 megahertz. So why not, and just do it. And then Mike had actually built one, and not for really high frequencies, I think, but he built it and was tuning it with a PTO. So it's really pretty good. It's an interesting circuit. It has two active devices, say two transistors, and you use the two transistors to meet the Barkhausen criteria, which you always talk about. You've got to get enough feedback coming back, and you've got to get it in the proper phase. It's got to go through one inversion, and then the second inversion is provided by the second transistor. So it comes back completely in phase with the signal at the input, and boom, off you go. Barkhausen criteria met. The other thing is, because you have such a robust signal coming back from the second oscillator, you could do very, very skimpy, very, very light coupling to the LC elements of the oscillator. I'm talking like 1, 2, 3 picofarads to the LC.
So you're not loading it.
You're not loading it, and it's not going to be affected by temperature changes in the active elements of the oscillator. So when you put this parallel LC circuit in the feedback path, coupled by just very, very, very lightly coupled, and what happens is any signals other than the frequency, the resonant frequency of the LC circuit, are just shorted to ground, and they don't make it into the Barkhausen land that we were talking about before. However, when you set the resonant frequency of that LC circuit to say 7.125 megahertz, that signal will not be shorted directly to ground. That signal will face a high impedance to ground, and therefore will be passed, and that becomes the frequency of oscillation of the circuit. People have claimed over the years that this is a really remarkably stable oscillator, and I found it to be true. I've done some pretty unscientific tests here, but I built this thing up to 20 megahertz, and it's pretty darn stable at 20 megahertz. I said it kind of flies in the face of a lot of the conventional wisdom that we've heard about oscillators. That okay, even Doug DeMoss said, yeah, you could build an analog LC oscillator up to about 10 megahertz, but beyond that, no. Doug was famous also for variable crystal oscillators because he just felt it was kind of impossible to get good stability. I know, Pete, with your love of the SI 5351, he shrugs. He does, stability. But I was intrigued by the whole Franklin thing because, wow, if you could get stability up to say 10 meters, wow, that changes the ball game in a lot of ways. So I've been fooling around with these things, and I built a few of them, and it's hard. They're definitely very stable. It's definitely an interesting circuit, and it's curious why it hasn't received more attention over the years. I went back and looked at a lot of the publications about the Franklin oscillator, and almost everybody who writes about it says, "Hey, this is a really great oscillator. I wonder why it's not getting a lot more attention in the ham radio world." You see this going back to the origins of the circuit in the late 1930s. You see it in articles in the 40s, 50s, 60s, 70s, all the way through. Every time there's an article, the author kind of concludes, "This is a good circuit. I wonder why it's not getting more attention." So that's kind of an interesting question. I think there may be an element of kind of circular logic here. If a few of the key authors have never built one, they don't put it in their book, right? Yeah. And then all the rest of us read the books, we don't see it, so we don't build it, so it doesn't get a lot of attention, and so I think this is something worth looking at, and I've built a couple of them. They've been kind of fun. Now, when you get down to around 7 megahertz, and you roughly compare kind of a Colpitts oscillator at 7 megahertz with a Franklin at 7 megahertz, you don't really notice a whole lot of difference. And I think part of that is because it's just not that hard to make a stable oscillator at 7 megahertz. I think the real test comes when you go above 7 megahertz. I've been talking to a guy who knows quite a bit about the Franklin, and that's Mike WN2A, who is a real homebrew QRP hero, and he's the guy who came up with what were known as the MOUSFET transmitters way back, I think 1996 or so. It was in QRP Classics, and then later he converted the VFOs to Franklins because he thought, because he just concluded that they were a good way to do stable oscillators. So we'll continue to talk to Mike about that. And I really appreciate his input. It's great talking to him. One of the other guys whose kind of work kind of sparked a lot of this was a Mike WU2D, who was building Franklin oscillators and did a video on it. And he showed it being super stable. He did it up to 21 megahertz. So thank you to Mike WU2D for pointing it out. And it's interesting. We'll see. Pete, stay tuned.
hey, Bill. There's that sounds like almost a circuit that's Hayward had in solid state designed for the radio amateur for the two N3904s.
I don't think it is. I think he said he did a tube. He had one circuit in there that was similar, but I didn't see anything about the Franklin. There are circuits that are similar that have 2 active devices, and I think Wes did have one of those in SSDRA, but not really the Franklin. So I'd have to take a closer look at that. I'm not sure, Pete. I'm not sure. But anyway, so it's been fun fooling around with that. Hey, sort of related, double sideband, my friend. Double sideband. That was double sideband. I said a while back that I think there were a couple of kind of centers of excellence for double sideband a while back. One was in Melbourne, Australia, with
Peter Parker,
VK3YE down there. But the other, ironically, or perhaps not ironically, maybe as you'd expect, was in Cuba. And there were a lot of rigs coming out of Cuba for double sideband. And I was looking into this, and I had heard largely through Arnie Coro, who's now a Silent Key, but who had the DXers Unlimited program on Radio Havana, Cuba for years. Arnie used to talk about some of the DSB rigs that they created. There were really two rigs. One was called the Islander, and the other one was called the Jaguey. Jaguey was named for a town in Matanzas, Cuba. The Islander, well, just the Islander, it was a tube type double sideband rig. The reason they went with double sideband is they didn't have any filters.
Yeah.
No filters. So double sideband was a natural thing. The other thing they learned to do was they learned how to use parts out of Soviet television sets. There were a lot of Soviet television sets on the island, and they were able to use these sets for parts. Pete, one of the stories that I heard while talking to guys about these rigs was really interesting. There was one little tube that they were using, and I forget what the designation was, a 6BA, something, it's the equivalent of like a 6BA6 or something like that. But it was known among the Cuban radio amateurs as the little spider. The tube was known as the little spider. And I kept thinking, why are they calling this tube the little spider? You know why? It was the Cyrillic lettering on it. One of the Cyrillic letters, the Russian Cyrillic letters, looked to them like a little spider. So all the tubes that had this little spider on it became known as the little spider tube,
wow.
which is amazing. But they did some really great work with the tubes in the Islander rig. And we have a couple of radio amateurs from Cuba who've been in touch with us and sharing like pictures and circuit diagrams from Islanders that they built. Later on, when things started going towards transistors, they built another rig called the Jaguey, which was basically a solid state version of the Islander. We have a lot more information about the Islander than we do about the Jaguey, but we're continuing to gather information. So if anybody's listening and has more info, especially on the Jaguey, please send it my way, and we'll fix it. We'll put it up here on the blog or in the podcast. But they had a lot of fun with double sideband and great stuff. Let's see. I already talked about how I blew up my nanos. Oh, one other thing I wanted to mention: mods to the MicrobitX. I did a set of mods. I basically went with Allison's KB1 GMX's recommended mods for the MicrobitX. And the objective, I think Allison had two objectives. One was to boost the amount of output available on the higher HF frequency bands, the 2N, especially on 10 meters. I didn't realize I was only getting about half a watt out on 10 meters, which was not enough. Allison, I think, also wanted to kind of level out the output so that across all the bands, the MicrobitX would have roughly the same output. So she recommended a series of modifications. One, she wanted to rip out 6 of the 2N3904s and replace them with metal can 2N2222As. I did this. I did this on the first one, just using a soldering iron, another solder sucker, and a lot of solder wick. Now, good thing the boards that Farhan provided were robust, so I didn't lift any pads, but it was kind of scary. So you know what I did, Pete? I went out and spent $35 and got one of these solder sucking irons that has the solder sucker built into the iron. Hold on a second, I'll show you. Here it is. Picture's worth 1,000 words. But this is an interesting piece of gear. Put on my headphones here for those of us who have the video connection. Look, there's the device, okay? It's just a soldering iron. And then it's got, look at this. It's got the sucker. See, there's the business end, all right? So if you want to take a 2N3904 part out, you just go to that part of the board, you put this thing down, you wait like 2-3 seconds for the solder to melt, then you hit the button, clock, boom, and it pulls the solder right out. And I'm telling you, it made my life so much easier when it came time to remove.
So like on the underside of the board, where
you just go to the other, you go to the other side of the board
and just do that
right there, and just you put it right. Okay, there's the lead coming out. Boom, boom, boom. It in like one shot, maybe two, will remove all the solder. So you go that, you do the 3 pins on the transistor, you flip the board over, you wiggle a little bit, boop, the transistor comes out.
Wow.
The transistors were in such good shape that I kept them because you could use them again. They're good 2N3904. So I removed 6 of those and replaced them with the 2N2222As.
The metal one.
Yeah, the metal ones. One thing, Lex PH2LB. Wait a second. Hold on. I want to get it. I want to get his call right here. Our friend Lex. oh man, Lex over there in Holland, PH2LB. Lex mentioned that when he did this, Allison also recommended changing the emitter resistors from 22 ohms to 11 ohms. So you're getting a lot more current through the transistors. Lex noticed that his 2N2222As were getting hot, too hot, hot to the touch. They were failing the DeMaw test. In other words, if you put your finger on it, it became uncomfortable. That's too much. So I didn't want to undo this because a big part of Allison's mod was increasing the current through these transistors. So what I did is I went out and bought a box of heat sinks for the 2N2222As. They're in 2018 cans.
Expensive.
And you can get them. Well, I got a whole box of them. But the thing is, now here's the thing. These transistors are close together, and the heat sinks look like little upside down
hats,
top hats. Let me see if I got the box here. Hold on. Oh man, probably put the box away. But anyway, when the transistors were so close together that the top, the flat part of the hat would kind of bump against each other. So I just clipped off like a third of the side of each one, right? And now they all fit in there really well. I put some Desitin, Desitin baby stuff on it with zinc in it as sort of a heat sink compound. And it works really great. These things will get warm, but they don't get hot anymore. So that took care of that. Then finally, the other thing is they Allison recommended changing like the pre-driver from a 2N3904 to a really hot transistor, a BFR 106. Those BFR 106 are a surface mount part. And at first I chickened out, and Todd K7TFC out there in Portland, he just came up with these little boards about the size of your pinky fingernail, but it's got the surface mount parts, and it's got 3 leads, 3 vias coming off. So it makes it a whole lot easier. So on the first mod that I did, I used Todd's board. On the second one, I removed the original tiny little surface mount 2N3904, and I started looking at it, and I thought, I got ambitious. Pete, I got ambitious. I said, man, I can do this kind of cold turkey. I could do this.
Surface mount.
I could just do it. And let me just try. So I had a surface mount part that I got from Mauser, and I cleaned up the spot. I actually put a little bit of solder on each part, and I did what you're supposed to do. I held it down with a little tweezers that I had. I just hit it with a little bit of solder, doop, 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 and I got it in there. So I got all 3 of them in there, just sort of cold turkey, just without the boards. So, I mean, the boards are great, and I really recommend Todd's boards, but it was kind of fun to get them in there just that way. So anyway, it worked out. Allison recommended changing one of the surface mount caps to 470 picofarad, and this whole set of mods, it had a good result. So the result was that I went from like a half a watt on 10 meters up to about 3 or 4 watts on 10 meters.
That's with 2 transistors?
I changed actually 6 transistors.
No, 2 IRF 510s.
Right, yeah.
There's 2.
Just 2 of them there, yeah.
2.
Yeah.
Okay.
Yeah. Now, I think some people could get a lot more because some people are running those 2 IRF 510s at 24 volts. But Allison was kind of, she said you're not going to get a whole lot of increase in output because the driver power is going to be the same. You're going to be driving it with the same amount of power. So I left it at 12 volts. So I'm getting 3 or 4 watts out. What do you think about that power output level with the 2 IRF 510s? I know you've been working on this, Pete.
Well, with 1, that's why I asked for 2. 1, I get about 2.5 watts.
Right.
So that sounds about right.
Yeah, you think it's about right? Yeah.
Yes.
So it's fun, and so now I got this thing going, and around the same time, elements for 10 meters and 15 meters for the Hex Beam arrived. Oh. So it's been like a busy time here. So I pulled the antenna off the roof. Actually, I got Freddie, the gutter guy, to come and help me pull it off the roof, and then I strung the 2 additional elements on the Hex Beam, and the thing went back up on the roof. And man, I am having a ball on 10 and 15 meters. I work now. I don't even have the amplifier hooked up yet. So this thing is just the 3 or 4 watts out barefoot, really barefoot from the MicrobitX going up to the 10 meter and 15 meter hex up on the roof. And I've worked the very first contact with this thing on 10 meters was Argentina, which is about 5,000 miles. Then just the other day, I worked New Zealand. The guy told me I was 5'9". He said I was blasting into New Zealand
Wow.
with this thing on 10 meters. And yesterday, conditions weren't great yesterday, and I was just fooling around, and I was exchanging text messages with Dean. Dean was KK4DAS. Dean was doing what he called BOTA, backyards on the air. He was out in his backyard with a rig and a wire antenna. And we started looking at what spots were coming in on 15 meters. And I think we both worked both of them. One was in Norway. We worked the Norway station. Then we both worked a station in Scotland. And then suddenly I saw the call sign of an old friend of mine. Hold on a second. I get my piece of paper fell down. An old friend of mine, Michael EI0CL from Ireland. And I saw him on 15 meters, and I gave him a call, and we had this great old conversation. Mike is just such an amazing guy, but we talked to him and had a great conversation. At the end, I said, "Hey, listen up for Dean, KK4DAS." Dean got to talk to him, so it was
Wow.
it was really good. And oh yeah, on the one other mod, once I got the MicroBitX working, I noticed that my nemesis across town here, the AM broadcast station on 1220 AM, 1.220 megahertz, was just overpowering the MicroBitX, and it was covering things up, especially on the higher bands. So I just said, damn, I got to do it. And I went and I built a little high pass filter with a cutoff at about 1.7 megahertz. I popped that thing into the MicroBitX box. Boom, problem solved.
Gone.
And I thought, this is exactly what Farhan had in mind when he came out with these rigs. He said he wanted to come up with something like the BitX module, the BitX 20, even the MicroBitX, where people would be willing to kind of tinker with and improve and modify. So I was really pleased to get that in there. Other early contacts on 10 and 15 minutes, I mentioned Argentina, Brazil, and then all of a sudden the Dominican Republic. Woohoo! Yeah, that came through. So a lot of fun on the air with those rigs. And Pete, just a sort of icing on the cake. Yesterday or the day before yesterday, I get on 20 meters, and this wasn't with the MicroBitX, but I heard him first on the MicroBitX, but then I wanted to have a chance to make a contact. I made my first contact with China using the Hex Beam, and it was a Bravo Alpha 4 Tango Bravo Dale near Shanghai. So that was really cool. And then I also worked an Indian station, a Victor Uniform 3 Tango Papa Whiskey. Great contacts, really both very nice fellas, and it was really, really kind of cool. I think conditions are getting better. Both these contacts were on 20 meters, but it worked both India and China. And I had rarely even heard China before, but now both of these on SSB.
You're a veteran.
That's it. That's it. So we worked these stations. Really cool. Anyway, I've rambled on enough about what's on my bench. Oh, one other thing, Farhan has the sBITX. He's taking orders. This is the SDR version of the BitX. Right now, I think they're still doing kind of beta testing, and he's got some people out there who are testers. But he's taking orders on the sBITX, and it's looking good, looking really interesting. So check out the HFSIGs website. Farhan's at hfsigs.com, and check it out. HFSIGs for Farhan. You'll find the sBITX there. Take a look. Pete, what are you working on? What's on your bench?
Shameless Commerce Division.
Oh, man, we forgot about the Shameless Commerce Division. Okay, a few things to mention. Thank you for reminding me, Pete. We had the Amazon ads on the blog went down for a while because of some mysterious reason. I suspect some sort of a Bezos-related conspiracy, but they're back up. So we have the ads now. So anytime you guys want to buy something from Amazon, use one of the ads They are on the left-hand side or the right-hand side of the blog. And cha-ching, we make some Bezos bucks here. Send us that stuff. The other thing is think about being a patron of the blog. Some guys have signed up as patrons. We try to send some additional info and content, as they say, in that direction. But we're really appreciative of all the support, and so check that out. The third thing is our friend out there in Portland, Todd K7TFC with mostly DIYRF.com, mostly DIYRF.com. He's got a whole variety of parts and boards. He's got TIA boards, termination insensitive amplifier boards. He's got high-cast boards. He's got ADE1 boards. You could basically source an entire SSB transceiver from mostly from the boards available on Todd's site. I have a link to the site on the blog. If you forget mostly DIYRF, just take a look on the right-hand side. You'll see a link to Todd's operation there. Check it out. It's really the kind of thing that we as home brewers really need. So definitely check that out.
I've been privy to some advanced projects that he's working on. Stay tuned, man. Stay tuned. Some exciting stuff coming. I mean, I don't think this guy sleeps. I don't think this guy sleeps. I mean, get plugged into his newsletter.
Oh man,
because he's going to be dropping some boards here this summer that are really exciting. Some exciting stuff.
Great stuff, and he's such a nice person too. So it's great. It's great to work with him. Pete, what do you got on your bench? What are you working on?
My time is very, very limited. Spending a lot of time traveling between here and the hospital and caregiving, so not as a lot. I envy the fact you can get on the air and workstations. Yeah, that was a thing of the past. One project I am working on is a 10-meter single sideband transceiver. And it's been documented on my blog, hamradiogenius.blogspot.com. And as a matter of fact, I've done another thing. I've been collecting all the postings on the blog, and I converted them to a Word document in a PDF. So if you go to n6qw.com, you can download all the over 2 months worth of postings. A lot of work has been done with the central to this is the BFR 106.
That's the part we were talking about before that I heroically soldered in.
Yes. So the transceiver has got mostly BFR 106s. Even the microphone amplifier is a BFR 106. And at 40 cents a unit cost, you can afford to put one in the microphone amplifier, and it really works well. And I've got an architecture similar to the P3ST. So the IF module is two BFR 106s.
Are you using surface mount BFR 106?
Surface mount, yes.
Are you using Todd's boards?
No, I designed my own board. I had a board, so I designed my own board. So I just used the parts. But I mean, Todd's boards would work. You just solder them right on. But a board I had already designed.
I gotcha.
With the parts. The steerable amplifier is a BFR 106, and a sleeper part. A good RF device is a 2SC5706 that you can get from W8DIZ.
Wow.
And the thing that's nice about this particular part, and it makes it nice from my construction built using the CNC mill. When it comes to a heat sink, I just cut out a copper pad, and you can solder that transistor right to the copper pad. So not only is it the connection point, but it's also the heat sink.
Wow.
So directly solder the tab right to it. That's the collector. Wow. 2SC5706, and they're really inexpensive. Matter of fact, I think Diz has an amplifier, has a 5-watt amplifier using this 2SC5706, but you can just buy the parts. So it's worth connecting to that. So anyway, I've tried to document. There's a lot of LT Spice simulations that are in that blog. So just about all the circuits have a LT Spice with the BFR 106. And just recently, I did one on using the IRF 510. So there's some documentation on the IRF 510 what you can do, which brings up something that I wanted to share a little bit about and to grouse a little bit about. Um, there's a group that's associated that's trying to build a P3ST, and I was a member of that group. And after a while, I said, "Look, I can't take this anymore. This is my design. Don't argue with me." You know,
Yeah, yeah.
I did it. It works. All I got to say is, here's the work. Just do what I tell you, and it'll work. But here was something that I used on the 10-meter transceiver was the bandpass filter. So guys are building the bandpass filters, and they don't have the right parts, so they're just putting parts in there. And then they get their nano VNA that they just got, and they measure it, and they say, "There's something wrong with your design." No, there's nothing wrong with the design. The problem is you're not following what you need to do to build this thing. And a good example is one individual took his nano VNA, and he got a very peaked response, and says, "What's wrong with your design?" Well, I said, first up, I know what the problem is. There's nothing wrong with the design. You have a wrong capacitor. There's a section coupling capacitor. If that section coupling capacitor is too small, you're going to get a peaked response.
Right. Yeah.
If it's too big, you're going to get a double hump saddle. You're going to get the cattle sound.
Yeah, sure.
So immediately, if you did your nano VNA, if you took the time to just understand what you're doing, you would know that's too small of a capacitor. Don't say there's anything wrong with the design. So, I mean, I bristle a little bit because guys get these tools, and all of a sudden, it's the tool tells me that your design is wrong. It's not. What you have is the wrong value of capacitor. So then a particular individual said you needed a 1 picofarad coupling capacitor between the sections. So how do you get a 1 picofarad? So I said there's 3 ways to do it. One, if you get solid state design for the radio amateur, Appendix 2, where Wes teaches you how to build a bandpass filter from scratch, he highlights getting that small value section coupling capacitor and shows you how to do it. That's way 1. Way 2 is to get a small value trimmer and a very precision capacitor. If you series those, it's just like the resistors in parallel. You can tune that thing to 1 picofarad. And the third is to use a gimmick. You can just get some twisted wires, gimmick, and cut it till you get the response that you want. Well, the answer you get back is, I've never built a gimmick, but that won't work because it's too floppy. Wait a minute. Wait a minute. First off, I use stiff wire.
Yeah.
And the other thing is you can buy chip capacitors, precision chip capacitors, 1 picofarad at 0.01%, and are 50 cents.
I know.
So I mean, you have lots of options, but you're arguing with me about I can't find small capacitors. You didn't look.
I know.
And you didn't listen.
I'm sitting here at my desk. I'm looking around. And I can't find any, so they must not exist.
Yeah.
I mean, the gimmick is such a cool thing. Actually, Mike WU2D, when he was building the Franklin oscillator, has 2 gimmicks in there. 2 gimmicks, and you could just trim them. You could just do whatever you want. They're great. You clip them off. Make another one. Heck, it's just 2 pieces of wire.
Yeah. And use the solid copper wire because then it becomes very steady. And if you build them such a way that you solder them down to a board, they won't move.
They won't. No, they're fine. Yeah, I agree. On the same topic, Nick the Vic, M0NTV, has a video out just yesterday on building bandpass capacitors. I just watched the first few minutes of it, so you might want to take a look. But Pete, we've had a similar experience with the students because our bandpass filter is just a dual tune circuit with one little cap between them.
Section coupling cam.
Yeah, and it's been really fun with the students to sit there and tune it and watch the response and get the response exactly as predicted. But it does require some tuning. If you don't have that center cap tuned properly, you could get exactly what you're talking about, a little peak right there. So yeah, it's a shame that these guys aren't smart enough or polite enough just to follow your advice.
Well, the thing is, they took the nano VNA and they took a measurement, and if they had spent some time with LT Spice, and I told them, build the circuit in LT Spice, change the value of that capacitor, make it smaller than what's shown in the schematic, make it bigger, and then look at your display on LT Spice, and you can see it. You don't have to build it in hardware. You don't have to put the nano VNA on it. You can see, well, if I make it too small, it's going to be peaked. If I make it too big, it's going to be double hump. And if I make it just right, I'll get a flat response. What's so hard about that? And then you
No,
argue with me.
I know. You know, the yeah, I mean the get the right response. Another problem with the Nano VNA is a lot of guys will charge right into it and they won't do the calibration. If you don't do the calibration, everything will be all screwed up. You know, so this is one of the reasons I kind of like Farhan's Antuino. He sent me an Antuino a while back,
Yes.
which is it's not a vector network analyzer. It's just a scalar network analyzer. It's an SNA, but you could just plug it in there and you get a good look at the filter passband. You don't have to worry about a whole lot of the calibration jazz, but it gives you a good picture of what that filter passband is. And so I kind of, I mean, I like both devices, but if I'm doing it quick and dirty and I just want to get a quick look, I'll just grab the scalar network analyzer, the Antuino, and take a look at it.
Sure. But I'm just saying, if you're going to do some home brewing, spend some time. First off, learn how to use LT Spice.
Yeah,
I mean, it's an
definitely.
invaluable tool because you can look at some things without building any hardware, and then you after a while you get a sense. Say, oh, that's got a peak response. That's the wrong size capacitor, or I got a nice flat band pass. That's the right size capacitor. So I tried to spend a lot of time with the LT Spice simulation so that you could look at it and have some feel what you're doing. So I'm getting close, but my time is very limited. I mean, you can't do much in 5 minutes.
No, you can't. No,
you gotta have. I mean, you obviously spend a couple hours working on something and finally say, okay, yeah, I got it fixed. But it's hard to do in 5 minutes.
I know. I sympathize.
So the other thing I want to just shift gears on.
Just one second about LT Spice. I agree with you. And I don't know, I mentioned this before, but we were really amazed because when we were doing the DC receiver, when we were sort of designing and tweaking it, we gradually built all 4 stages in LT Spice. And I was just treating them as sort of discrete stages.
No.
But then all of a sudden in LT Spice, I connected them. And then I kind of looked away and I looked back at the receiver and it was firing up in LT Spice.
Yes.
I mean, it's not a surprise that the amplifier or the bandpass filter or even the mixer work, but I never expected the oscillator to meet the Barkhausen criteria in LT Spice and show oscillations. Then I could tune it. I could say, okay, let's pretend that we have a little signal at 7.1 megahertz, and let's set the oscillator to 7101 and see if we get a 1 kilohertz audio output. We did. And I was joking with Dean. I said, all we need to do is hook up an antenna and a speaker, and boom, we've got an SDR transceiver or receiver anyway. Great. But go ahead. But you were going to say something.
And the other thing I just wanted to mention is the last podcast I spoke about a tube type transceiver that's in the future drawing boards, and the need to heterodyne the Collins PTO. And I mentioned that Adafruit had this neat board. And then someone sent me an email about Hans Summers at QRP Labs has this thing called programmable rocks.
Yeah, the Prog Rock. Yeah.
Prog Rock.
Yeah.
And these are little boards that actually have a micro USB connector on it so that you can load the frequency in and then the unit will spit out either 1 or 3 frequencies on the board based on what you program. But the thing that's interesting is he sells it in different configurations. He has one that looks like a 8-pin dip. He's got another one that's got a 2x6 header that you can plug in, and another one he shows he actually built it inside of a crystal can. So you take the crystal, you cut the bottom off, you plug this thing in there, and you solder the thing back on, so it looks just like a crystal, and you plug it in the circuit. So they're about $18.
Yeah,
and you got to tell them what you want.
It's a really neat little idea. It's, as I understand it, it's basically just the SI5351, but without the microcontroller, without the Arduino.
Right. As a matter of fact, Spectrum Silicon Labs now Skyworks has a utility called the clock oscillator, and this clock oscillator utility lets you set the numbers so that you can program it. And I think there's an EEPROM right on the little board that sets the frequency. Once you program it, it always boots up to that frequency.
There's a guy in the UK who built a direct conversion receiver using one of these prog rock devices. And what he discovered through messages from Hans was that if he put 3 switches on a board, by changing the configuration of the switches, he could jump around to multiple QRP frequencies. Now, I just said, I was joking with Dean. I said, man, it gives me a headache just trying to remember what the combinations of the switches are. But it's a neat use of the technology, and he's built himself a really interesting DC receiver. We'll have to put that up on the blog and get that video going. But interesting stuff. So, man, Pete, you're doing a lot in spite of the adversity that you're facing. So, anyway, great stuff. Hey, listen, should we do mailbag?
Yeah.
We're already over time, Pete. We mentioned Wes, W7ZOI. He's been so helpful on so many things. He provided great info and analysis on the Franklin oscillator. And in the course of doing so, he also passed along a whole lot of technical info that he recently put up on his blog or on his website. And it's w7zoi.net oldtech/ponder.html. I'll put the link up on the blog. But a bunch of articles that haven't really made it onto the internet yet. A lot of great stuff in there. I mean, he's just such a prolific technical guy and great writer. So, I mean, I'll put this up there. We mentioned PH2LB and the uBITX mods and the TO18 Heatsinks. But Lex is involved in another project with us, Pete. I'm going to reach to it over here. It's this thing. Yeah, it looks like I might be not mirroring, but it's the a replacement sticker. We need a new sticker, and I'm going to put the sticker that Lex came up with. I'll put it up on the blog, and we'll invite comments. We obviously needed to do something about the IBEW reference because there were a couple of reasons. One, Brotherhood might not have been quite inclusive enough, because one thing we're finding out in the high school project is that there are a lot of women who are interested in this stuff, and when we say Brotherhood, it's kind of off-putting, I think. So we'll get rid of that. But also, it's confusing with the labor union. People in the States look at it, they think it's some sort of union thing. The IBEW, nothing against those guys, but this is an entirely different activity. So for us, it was the International Brotherhood of Electronic Wizards. All right. And so, but anyway, we're looking for a new sticker, because we're into sticker culture. We were out in Charlottesville not long ago with my daughter, and as we walked around town, I spotted a whole bunch of stickers that I put up there on a previous visit. I said, "Who is this? Holy cow! SolderSmoke is sweeping the nation." Got some great email about the Franklin oscillator. You mentioned Hans, G0UPL. Hans has a Franklin oscillator up on his site, tube type, but he was ahead of the game on that. And a guy who's really been responsible for the recent embrace of the Franklin oscillator at global levels, I would say, is Kostos, SV3ORA. I mean, if you want to take a look at a site with a lot of interesting stuff, just check out Kostos's site. Just do a search for SV3ORA, and man, you could spend a lot of time in there looking at the interesting circuits that Kostos has made, including the Franklin oscillator. And Kostos is actually the guy who encouraged Mike WU2D to take a look at this circuit. So Kostos is the guy responsible for this wave of Franklinism that's sweeping the planet.
Then you got to look at the Butler oscillator.
The Butler oscillator. It's similar to the Franklin, right?
Yes, it is.
All right. So that might be the one that Wes had. It might be. We'll take a look. But anyway, thanks to Kostos and to Hans. Hey, listen, Pete, I want to mention something. I don't spend enough time listening to other podcasts. But I did the other day, and I just fired up Ham Radio Workbench, and I was looking at what they'd done. And the one thing that caught my eye was Ham Radio Workbench number 178. They were talking about SatNogs, which is a worldwide network of VHF and UHF. And that's the thing. I didn't realize that the guy that they were interviewing, the guest that they had that time, was your old friend, Ben. And I don't. His call sign recently changed.
AI6YR.
AI6YR. What an interesting guy. And I checked out his QRZ page. He's into the old radios. You must have influenced him there, Pete, with a TR7 that I see in the background. But a lot of good stuff and a lot of good information on SatNogs and the receiver. This is of interest to us because the local high school put up a CubeSat that they're still working on. And so I was interested in SatNogs, but I just started listening to this stuff, and I was amazed. Okay, there were so many kind of old friends that came up on the podcast. First of all, George Zaff, KJ6VU. George used to be one of the sponsors of the SolderSmoke Podcast. He had a repeater controller that they were working on, and so for a long time they were sponsoring it right here. That's how we got to know George. George was a Silicon Valley guy up there in the valley. He's since moved. He's moved out to Oregon. He has more room, hopefully for antennas and things like that. And he's bought a ride-on lawnmower, and was talking about that. I told him, I said, George, you're getting ready for 75 meters. Next, you're going to be talking a lot about raking leaves and cutting the grass and ailments. So be careful. Then the guest host that they had on, another guest part of the team, is Thomas K4SWL, who's got the Shortwave Listening Post blog and the QRP blog. And it was so great to hear him. In the course of him talking, Thomas is talking, he just casually mentions somebody that he's been working with, Jeff Whitlach. Jeff was on the podcast a number of times. Jeff is the Piper Cub guy who had the yellow Piper Cub. And it was great to hear about him. Then Ben comes on. Ben starts talking about SatNogs, and he just casually mentions, and this really blew me away, a guy that I know, John Zaruba K2ZA. I have the DX100 that belonged to John's dad.
Small world.
Right there. And Ben just mentions him, and he's been working with John on a number of different projects. So there was just all kinds of great, wonderful connections there. And it's just a lot of fun when you start running into old friends and people that you've been in the hobby with for a long time. So I thank George, KJ6VU, and all the guys from Ham Radio Workbench, and I'm going to be listening some more. We'll listen. It's worth listening to. Those guys know which end of the soldering iron to grab, Pete, as we say. Hey, another guy who knows which end of the soldering iron to grab is Todd, VE7BPO, QRP home brewer, home builder, right? Popcorn QRP. This guy was an amazing font of information about QRP and home brewing, still is. And I went out to the mailbox the other day, and there was a little box there, and I said, well, what is this? And I opened it up, and it's from Todd, VE7BPO, and he's sending me a really precious item.
Yes.
An AADE LC meter, almost all digital electronics LC meter, made by Nick himself, the guy who founded the company, who's now a Silent Key.
Awesome.
But these devices, we were using them when we were working with the high school kids, and I was reluctant to take it out of the shack because I said, man, if this thing blows up, there are no replacements. Yeah. So, but anyway, now Todd sent me another one, and that one of them is going to go to the SolderSmoke Shack South, because God knows I need two of them. Let's see. I mentioned Nick, M0NTV. He's got the video out about the bandpass filter, but he is like me, Pete. He is planning a 15 and 20 meter dual bander. He and I talked a little bit about some of the early planning that you have to do with a rig like that. He's kind of different. He's going for high VFO injection, high side injection. Yeah. And he's going to use an SI 5351, I think, running up about 31 megahertz. I, of course, I'm looking at low side injection because I got to keep the VFO frequency fairly low. But I'm still toying around with this thing. But I think I like his idea of a dual bander. You know, the mono banders, we've been building mono banders for a long time. You get kind of tired of mono banders, but I think a 5-bander is almost like too much. There's too much switching. There's too much stuff going on in there. The dual bander seems to be like the sweet spot. So this would be my third dual bander.
You know what I like about a dual bander is you have one toggle switch, a double pole, double throw toggle switch. You switch it, especially using an SI 5351, loads a second band in there. In the second half of the double pole, double throw switch, controls a bunch of relays that changes the bandpass filters and the low pass filter. One switch.
I know that's what
so,
I got. I have one switch. I have two dual manders. One is the Mythbuster, which is 75 and 20. The other thing I do along the same lines is I have the LCD readouts from Sanjian. This is the only kind of part that I didn't build. It's just it's got a PIC processor in it. But on the Mythbuster, I had two different LCD displays, one for 75 and one for 20. And when you threw the switch, one lit up and the other turned off.
Yeah, there you go.
I figured out by the time I built the second one, which was for 17 and 12, I figured out how to do it with just one LCD display. So when I turn the switch, the display displays 24.9 megahertz, and I put it the other direction, it's 18.1. So it's fun. Dual banders. Yeah, I think that's the way to go, Nick. Hey, we've been getting some email from Trevor Woods in Western Australia, and we've been talking about Artie Moore. I didn't know about Artie Moore. Artie Moore was a really early radio amateur. Artie Moore was a Welshman who had lost his leg as a kid, but he got really interested in technology very early, spark technology, coherers. He was using coherers, and he set up a radio station in a shack. He actually had a shack in Wales, and he actually monitored the CQD transmission from the Titanic. He went and reported it to the police. They thought he was crazy. They didn't pay any attention to him. But he actually monitored that. Now, we were looking at the pictures because there's some really fantastic pictures of this guy's rig from very early days. And there's a big picture of a guy on the wall. And I said, who is that guy? And we found out who it was. He's got a picture on the wall of William Ramsay, who was a UK chemist who won the Nobel Prize for chemistry, I think, in 1914. But we found out who it was through Chuck, WB9KZY, who took the picture, just put it into Bing, and Bing was able to identify it just through its visual search. Hey, one other thing from Norway, Helge, LA6NCA.
Oh, neat.
He had neat stuff. What happened to your picture? Your picture faded a little bit. Did the light change? The sun coming up?
Yeah, sun's coming up.
Sun's coming up in California.
So I got an aurora about me. It's the fake Pete.
It's not. People are going to say, I know at that point you put in chat GPT. No, it's just Pete. The sun is coming up in California.
Yeah.
All right. Anyway, Mike, Helge, LA6NCA, he built this two-tube transmitter, spy transmitter on an Altoids tin. And then he followed up just a couple weeks ago with a 3-tube receiver. All right.
Yes.
Now, the question I have is, the first stage is obviously an RF amplifier. The third stage is obviously an AF amplifier. The question is the second stage. Is it a regen or is it a direct conversion?
Mm-hmm.
We don't know either. And I asked Helge about it. Helge kind of said, I think it's direct conversion, but he didn't seem certain. Mike, WN2A, is inclined to think that it's sort of a combination of them both. But I don't know. I'm not quite sure. It looks to me it's more like a converter circuit. Remember those old converters where you'd have one tube would have an oscillator in the tube and a mixer? It wasn't a regen. It was more of a converter. So we'll have to see about that. We're still talking about it. Mike W2D, not only did he do the Franklin oscillator video, but he did this wonderful video about retro QRP rigs from the 60s, 70s, and 80s. Holy cow. There were some fun rigs there. A lot of HW7, HW8, Power Mites, Argonauts, all kinds of good stuff. And he even mentioned
all marginal.
Yeah, yes. He mentioned the Severn rig that George Dobbs G3 RJV had put out. And Steve G0FUW sent me an email, and he said that he was really glad to see discussion of the Severn rig, and he's still working on his. He started in 1983 on it, and it's nearly finished.
Marginal.
Well, I just said, listen, you got to be patient with these things, Steve. I started working on my Hearing Aid 5, I think, in 1976, and I just, got it finished 38 years later. So these things take time. Tim Hunkins of Secret Life fame. did a great video, and he made a speaker. He did a video on solenoids, and he made a speaker out of an old potato chip bag. So Tony G4WIF and others were discussing this and discussing what kind of potato chips he was using. Anyway, we also discussed, Tim did a video on how to cut holes in metal. And I've got links to that, links to both videos, I think, on the SolderSmoke blog. Bob Crane, W8SX, will be covering FDIM, the 4 days in May event for SolderSmoke.
It's already around again, isn't it?
It's coming up. Yes, it's later this month. Yes. Once again, Pete, you and I are not going.
You bet.
We'll be there in spirit. We'll be following and be waiting for Bob Crane's reports. Gene, VE3DNL, is working on a DC receiver. His is a bit more sophisticated than ours. Good luck with that, Glenn. Glenn, VE3DNL. Craig, KC2LFI, has been operating from the beach in Grand Cayman. Yes, ooh, where people go for the beaches and to visit their money. So we hope you're doing a bit of both there, Craig, but definitely a good, fine business on the operation from the beach. Got a great email from Steve, EI5 Delta Delta, and he's the guy who puts out the fantastic radio newsletter. They have changed the name, and I think it's good. It used to be like the Connaught Radio News, and I always found that I couldn't quite figure out what they were talking about, but now it's called Ham Radio Ireland Magazine, which is perfect. There you go. Yeah. And it's Ireland's only independent magazine for the radio experimenter. This is something that Mike and I were talking about. Not radio amateur, the radio experimenter. All right. Good stuff. And I got a link. The link to it is up on the blog. I talked about our conversations with Mike, EI0CL on 15 meters. Howard, N3FEL of the Penn Wireless Association. He wants to do a group build of our high school direct conversion receiver. Good luck with that, Howard. Please keep us posted. That's really interesting. On the blog comments section, we heard from Martin, Lima Whiskey 9 Delta Tango Radio down in Buenos Aires. And he's looking for help trying to get the code going on an AD9850.
What was his specific question about?
He was, I think he was having problems loading the code or getting the code to work, and he was looking for help on that. So I could definitely sympathize because been there, done that, had that problem. And one guy pledged to come to his assistance, but I don't know whether Martin has followed up or not. Martin, he might be in the phase where he's removing all the parts from the board out of sheer frustration. So hang in there, Martin. We'll help you, buddy. And you're not the only one who's struggled with these kind of things. Todd, K7TFC, we mentioned him. He's always helping other home brewers. We see frequent examples of Todd putting together care packages and dispatching them to the world. And finally, there was a really nice message that you got, Pete, from Kevin, WN7Z. He sent a real nice message about the podcast and how much it means to him and all the help that you provided over the years. So great stuff. Pete, 1 hour,
30 minutes.
To what? Has it gone on that long? It was showing here.
Yeah, it's 7:30.
Holy cow. Yeah, there we go. So good stuff. We've covered a lot of ground here, Pete.
You bet.
And listen, I know you got all things to do. Good luck to you. Good luck at everything. I hope your wife's feeling better. And we'll be talking again soon.
You bet.
And listen, next time we might have you singing the praises of analog oscillators. And talk trash about the SI5351. But that would be the robotic Pete. I don't think it's going to happen. All right. 7-3 from Northern Virginia.
7-3 to the left coast.
Thanks a lot, Pete.
Bye-bye.